Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 11.2.1, which is the volume of a pyramid. And we have a three-dimensional solid made up of flat polygonal faces called a polyhedron. A pyramid is a polyhedron formed by connecting each point of the polygonal base to a single given point, which is called the apex. That is above or below the flat surface containing the base. And so each triangular lateral face of the pyramid is formed by segments from the apex to the endpoints of a side of the base and the side itself. So it says obtain a set of four pyramids and answer the questions below. And so we've got three of the pyramids right here. We're supposed to sketch them all on paper. Now, a lot of this is going to be you guys going to be cutting them out and then trying to form the pyramids. We know that they all form the pyramid by having an apex at the top that's a singular point. The bases are going to be different, though. If you notice, the left one right here is a triangular base. This one right here in the middle is a square base. And the one on the right side here is a hexagonal base. And so we can go ahead and describe those pyramids in words using part B right here. So pyramid with triangular base. Pyramid with a square base, and a pyramid with a hexagonal base for the last one. Pyramid. Cool. All right. And so that's what we were supposed to do for part B here. We're supposed to choose similar and appropriate names for pyramids described in part A. So in part C here, it says, what are the surface areas of pyramids B and D? Use a ruler to measure the dimensions of the edges in centimeters. And so that's mainly going to be kind of your thing, but I'll just show you how you would go about finding the surface area of each pyramid here. Now, we've done this a lot with prisms. I would just explode this thing into a net. And so that would be the base right here. So this is the base. And then go ahead and draw the individual pieces here. So you would just kind of explode them down like that and find the individual areas and add them all up. So same thing here with the square base pyramid. Just go ahead and make your square base. This is your base. And then you would just find the surface area, find the area of each one, and then add them all up. And then of course the hexagon would do the same thing, where you would, and this is going to be the worst of them, but I think you kind of get the idea. And that's okay if it doesn't look that good, but I think you guys kind of get the idea. The base would be a hexagon, and then you add up 6 triangles to get the surface area of that. So that's going to be how we find surface area of a pyramid. There is a formula for it, and eventually I might roll it out to you guys, but for now I think if we want to keep things consistent with how we find surface areas of these three-dimensional prisms, I think exploding it into a net would be the most consistent thing we could do. So I'll be right back with the next problem. So in problem 11-41, you're supposed to do a lot of exploration with the physical models you have at your tables, but ultimately what you're supposed to get out of this idea is that the volume of a pyramid is going to be 1/3 base times height. Now this B here, what it means is it means the area of the actual base. And so the reason why that's important is because sometimes, as we saw in the last problem, is that the base can be different shapes. The base could be a triangle, the base could be a square, the base could be a hexagon. And so we definitely want to be mindful of what the area of the base is. Then we just multiply it by the height, divided by 3, and then we're all good. So now we're going to help Soraya decide which tent to buy for her backpacking trip. And so what we're going to do is we're going to compare the volumes, base areas, surface areas of both tents, and we're going to share this out when we're done. So let's go ahead and take a look at tent A. Tent A isn't even a pyramid. All right, it's a prism that is triangular based, and so it's square based if we look at it from this perspective. But in a minute we're going to need to see it as a triangular based prism. But let's go and compare the base area. So in this case, the base area is going to be, looks like the base is a square in this case, if she's going to be setting it down like that. And so that's going to be, it looks like 6 times 6, which is going to be 36 inches squared. Let's take a look at the surface area of tent A. Tent A is going to be comprised of 2 triangles, one in the front, one in the back. So I know it's going to be 2 triangles. Whoops, I'm going to just draw this out a little bit larger here. 2 triangles. Looks like 1 square, right? 1 square. And then 2 rectangles. So again, this is just, instead of me drawing out a net, I'm doing it the Lego piece style. Some of these are pretty easy to find. This is going to be 6 and this is going to be 6. And so that's going to be 36 down here. 2 of these triangles is going to be 1/2 base times height. So the base is 6 and the height is 5, but there are 2 of them. The rectangles is going to be the hardest part. In order to do that, I'm going to go ahead and see this as something a little bit odd. Well, I know that the base length is 6, but this height here is going to be correspondent to what I just highlighted in purple on the figure right here, this thing. Well, how do I find that out? Well, what I'm going to do is I'm going to go ahead and draw a right triangle to capture that piece right here, whose height is 5, and by cutting it down the middle, this is going to be a 3, and I know what you're thinking. This is going to be 4 based on a 3, 4, 5 right triangle, but that's not true. The 5 would have to be the hypotenuse for that one. So we can't exactly go that far. We actually have to use the Pythagorean Theorem here. So that's going to be 3 squared plus 5 squared equals c squared. That's going to be 9 plus 25 equals c squared. So I'm getting c equaling the square root of 34. So that's going to be the square root of 34, and there's 2 of them. So it's going to be 6 root 34 times 2. So what happens when we multiply this out? We're going to cancel those out. We're going to get 30 plus 36 plus 12 root 34. So I get 66 plus root 34 inches squared. But I kind of want to figure out what that is. So after I calculate all that into a calculator, the surface area is going to be 135.971 inches squared. So here we go. We got a base area already. We've got a surface area already. Now we got to find a volume. To find the volume, I'm actually going to tilt tent A onto one of its sides, onto one of its faces. And so from here, I'm going to put the triangle side as the base. That way I know for sure what the height is. Well, remember, the volume is going to be, it's going to be the area of the base times the height. The height is 6, right? And the reason why the height is 6 is because my height is now going this way. I remember I'm tilting the tent on its triangular face. So now I just need to find out the area of the triangular base here, which isn't too hard. It'll be 1/2 base times height, which is going to be 3 times 5, which is 15. 15 times 6 is 90 inches cubed. And that's going to be the volume of tent A. So we have a surface area, a volume, and a base area. And then we'll go and compare that to tent B. Tent B is a hexagonal shape, pyramid. So let's go and find the base area. So the base area is a hexagon. So I'll go ahead and just draw a quick little hexagon right here. And again, I hope at this point, and it has a diameter of 8, which means it has a radius. It has a radius of 4. Now at this point, I'm hoping we're comfortable with the notion that I can just break this thing out, call this 4, call this 60, make this 2, and make this 2 rad 3 on special right triangles. So the base area is going to be 1/2 base, which is going to be, if this is 2, that means that this is going to be 4. So 4 times height, which is 2 rad 3, times the number of triangles, which is 6. So that's going to be 2. So 24 rad 3 is the base area. So let's go and find out what that is as an actual calculation. So the base area is going to be 41.569 inches squared. So that's our base area of our hexagonal tent. the surface area is going to be, well, I'll go ahead and just do the base area plus 6 of these triangles that extend out. So that shouldn't be too hard, I'm thinking. Well, I know that this is going to be 24 rad 3 plus 6 times whatever the area of this triangle is. Well, from here, I do know a couple things. One, I do know that the base of this triangle, I do know that it's 4. Now here's where you're going to make your mistake. You're going to think that the height of each triangle is 6, but that's not true. The height of the pyramid is 6, but what we need to find is we need to find the height of this slanted triangle. Now sometimes books refer to this as slant height. So how do I do that? Well, from here, if you look at this three-dimensionally, if you look at this figure three-dimensionally, it looks kind of like this, right? And so from here, if I break him out, this side here is going to be 6. This side here that is the from the center all the way to the edge, well, how much is that? Well, that's 2 rad 3 because it's the same dimension as the height of the hexagon, right? So the thing that's in purple that I'm highlighting right here in dark purple is the same thing as this thing here, which is the same thing as this thing here. So a little bit of 3D thought there. It's a little bit weird, but hopefully you can connect the purple things together. I'll even do it in sky blue. That way, we can make that connection even better here. Sky blue, and sky blue. So they're all the same. So I got to use the Pythagorean theorem to find out the slant height here. So that's going to be 6 squared plus 2 rad 3 squared. That's 36 plus, looks like 4 times 3, which is 12. So 36 plus 12 equals c squared. So 48 equals c squared. So c equals the square root of 48 or 4 rad 3. So that is the height of this triangle right here. So that's going to be 6 times 4 rad 3, right? So 6 times, So that's going to be 6 times these areas. So that's going to be 1/2 base, and the base we determined of this thing to be 4, and the height is 4 rad 3. So the hardest part here, it's actually not that easy. The hardest part is going to be figuring out that hexagonal slant height right there. So hopefully that's not too confusing. That's going to become a 2. So 2 times 6 is 12. 12 times 4 is 48 rad 3 plus 24 rad 3. So it looks like 48 plus 24 is going to be 72 rad 3, which ends up being, as an actual number, 124.707 inches squared. So this is your surface area of your pyramid here. To find the volume of this pyramid, we're going to employ the 1/3 area of base times the height, because we are dealing with a pyramid. So the area of the base is not that bad. It's going to be 24 rad 3, that's the area of our hexagon, times the height, and this is where that 6 comes in. The 6 comes in here, right? That's the height of tent B. So that's going to be times 6, which is going to get us 144 root 3, but I'm taking 1/3 of that, so I'll go and divide the whole thing by 3. So let's find out what this is going to be. Looks like I'm going to get 83.138 inches cubed. So in order for us to determine which tent Soraya should purchase, I don't really know if they even have a straight answer, because it looks like, in terms of materials that are being used, it looks like the total surface area of each one, so 135 versus 124, it looks like tent B has less surface area, and then of course holds less stuff, because the volume of tent B is smaller than the volume of tent A. I mean, I guess it's entirely up to her which one she wants to buy, or which one she wants to bring. With the surface area of 10A being larger, that might mean that it's heavier. But yeah, I guess it would just be entirely up to Soraya. So hopefully this makes sense in terms of how to find the volume of a pyramid and the surface area of a pyramid. 10B got a little weird because of the hexagonal shape, but we will do plenty of practice of those. That way you get used to finding slant height more effectively. But that will wrap it up for this episode. I will see you all in the next one. Please leave comments or questions in the comments area. See ya.